Good afternoon, sir. Can you able to hear me, sir? Maheshwaran, sir.
Sir, good
Good
afternoon, sir.
afternoon, sir.
Good afternoon, sir.
Yes, sir. Good afternoon, sir. We will start the session within the 5 minutes, sir.
Okay, sir. Okay, no issue.
Okay, sir. Thank you, sir. Good afternoon, participants. The session will be started within a few minutes. start the session, sir. Can
Sir?
we start, sir?
Yes, sir. Yes, sir. No issue.
Yes, sir. It's my immense pleasure to welcome our today's resource person, Dr. S. Maheshwaran, Associate Professor, Department of ECE, Kongu Engineering College, Ero, for this AICT sponsored 6-day short-term training program on research challenges and application of Internet of Things in agriculture. Welcome, you, sir.
Yes, sir. Thank you, sir. Thank you.
Yes, sir. And I wish to welcome all the participants for the short intro about our resource person. If we had no winter, the spring would not be so pleasant. If we did not sometime taste of adversity, prosperity would not be so welcome. Let us see about his biography. He completed his UG in University in 2002, and he completed his PG in Applied Electronics from Anna University, Chennai at 2004. And he obtained his doctoral degree in embedded system from Anna University, Chennai at 2016. His main area of specialization are instrumentation, automation, and IoT. He possesses 16 years of experiences in teaching field. Presently, he is working as an associate professor, Department of ECE, Kongu Engineering College, Europe. He published 19 technical research presented more than 31 papers in various national and international conferences. He acted as the chairperson of national conferences and workshops and so on. And also he organized several funded programs like seminars, conferences, others during his curriculum. He did the various consultancy projects for several reputed companies, and also he did several funded research projects from different in IST, IET, and IEI. He received an Best Faculty Award in the year of 2005 to 2006, and he received a Young Scientist Conclave Best Hall Presentation Award at 2016. And he also got the Best Project Award in Chennai Science Fest 2017, conducted by Tamil Nadu. He is a successful person who leading a best professionalism in his career. There are the three things to aim at in a lecture speaking. First, get into your subject, then get your subject into yourself, and lastly, to get your subject into the heart of your audience. Our resource person, Dr. S. Maheshwaran. Now I request our resource person, Dr. S. Maheshwaran, to deliver his speech on the topic of research challenges and application of IoT in precision farming. Please, sir.
Thank you, sir. Thank you for your introduction. So before start
Thank you,
of my
sir.
session, I would like to thank the managements and the principals of Kongu Engineering College and the Kongu Nadu College of Engineering and Technology for providing me an opportunity to interact with you people. So from this, directly
It's our
we may
pleasure,
get in.
sir.
Yeah, thank you, sir. We may get into the subject. So I hope the screen is visible to all.
Yes, sir. It's visible, sir.
Yeah, thank you, sir.
Thank you.
So here I'm going to divide that entire agriculture sector into three different segments based on the technology requirement. So here the very first one is which I'm going to consider is under the soil, that is the base, and the second one is on the soil, that is the second layer, and maybe if you take the third layer, you will be having above the soil. So in entire presentations, I am going to, or even if you take in agricultural field, you can divide that entire system into these three segments. Okay, so the very first one is under the soil, and the second one is on the soil, and the third one is above the soil. So we are going to monitor or we are going to control different parameters only in these three layers. Of course, we can include one more layer that is for power purpose. Maybe we can consider the fourth layer, that is that maybe you can call it as your energy layer. But that is common to everywhere. But here we are talking about research challenges in agricultural sector, and that too, how this IoT is going to help the farmer in terms of technology and in terms of quality and quantity. So if you take this under the soil, maybe in sometimes we are going to monitor the water and nutritions, so which is available under the soil. That means maybe based on your water nutritions or water chemical parameters, we may do some kind of activities or we may measure something. And if you take the second layer, there we are going to take the soil. Maybe in the soil also we are going to concentrate on again soil parameters like pH value, conductivity value, or temperature like that. So this is your second layer. And if you take the third layer, that is above the soil, that is we are going to monitor the crop. So in that third layer, most of the times we are looking for the result oriented. That means based on your two bottom layers, we are going to get the result in the third layer. So maybe for disease control or for monitoring purpose, we want to have some kind of interaction in the third layer. Okay, we may measure different parameters in different levels. How we are going to do the communication? Maybe after the measurement, you can communicate your information to the next hierarchy. That means maybe your agricultural officer or maybe your agricultural university. So by measuring any of these parameters or combination of different parameters, you supposed to send those information to your agricultural university or officers. So the basic thing is your IoT. Maybe you can use your IIoT or artificial intelligence for on-field feedback systems. Maybe you can use artificial intelligence. That means within the field, you can do some kind of analysis. You can do some kind of recommendation for the farmers. Then some situations or some parameters maybe we supposed to discuss with the other maybe your other farmer or other agricultural officers. So we want to have some kind of communication that we are going to make it through your IIoT or IoT. Okay, most of the times we are forget to, that is in the agricultural field, we are forget to maintain the database. So to maintain the database, maybe you can use your cloud storage. And if you are going to keep any data or any information into the cloud, maybe that is common for different persons. They may access, they may give some kind of recommendations, they may do some kind of predictions. So after getting those informations or after getting the feedback, maybe you can send it to your directly to the farmer, or maybe you can directly control some kind of parameters. So if you take the entire agricultural sectors with respect to your technology, that means your electronic side, we are going to have only these component. Okay, maybe your field, then your communication, then your storage for your retrieval purpose. Okay. So here I am dividing that entire systems into different layers, and in that layer, different parameters. Which are all the parameters prominently we are going to measure or we are going to control it. So if you take the under the soil, that is very first layer, that is the very bottom layer. So in under the soil, I'm going to take water level, or what is the pH value of that water, or what is the electrical conductivity of that water, what is the temperature of that particular water. So these may be a primary. You can take the secondary content also. Okay, that maybe we will discuss later. So after getting all these informations, maybe you can activate, you can control something. Say maybe you can activate valve, or you can activate your pump, or you can shut down your pump based on the water level availability, or based on the moisture content. You can switch on or switch it off your valve or pump. So this may be your very first layer data. So here I'm taking it as in terms of edges. Okay. So in the second level, in the second layer, or you can take second edges, we are going to concentrate only on the soil. So what is the soil electrical conductivity? What is the soil pH value? What is the moisture content? What is the temperature values? So all these things we are going to measure it. Of course, the control element that already included in the bottom layer itself. And if you take the next one, that is your third layer. So that is H3. In some cases, we are going to monitor the external environment. Okay. So if you take other countries like Japan and all, they are cultivating crops under greenhouse because of different reasons. Even in India, if you take, there are different problems farmers are facing because of your climatic condition, because of your animals, because of birds. So we want to we want to cultivate your crop, or maybe most of the cases vegetable. So for that, we want to have a closed environment. So in that closed environment, we want to measure different parameters like indoor temperature, indoor humidity values, what is the CO2 level, what is the radiation present in it. And in addition to that, maybe we can consider the outdoor parameters like temperature, outdoor humidity value, outdoor wind energies. So based on all these informations, maybe you can activate certain parameters. Here I'm quoting only two things. One is your air conditioner and another one is heating, only with respect to this. Maybe you can include your radiation also. So this is your third level, or we call as third edge. Of course, the fourth edge is energy. If you take other applications where we want to, we may take the energy from your EB supply. But if you take this agricultural applications, we supposed to get, or we are going to operate all these instrument in a remote location. So to get power for that particular product which is kept in, under remote location, so that is actually a tedious process. So one of the natural energy source is your sunlight. So maybe you can use your solar panel to get your sunlight information, that is your solar energy, and you can save it in your battery. But here we are operating your instruments and your control and other sensor elements using this particular battery. So we want to do some kind of measurement in this particular, that is your battery management system also. So that's why here I have included, that is what is the power consumption, what is the energy generated, is there any leakage of power, that means due to the short circuit, something like that. So, so we want to have some control, kind of control element here. So that is your fourth layer. Okay. After measuring all these things, where we are going to communicate? Yes, of course, we are going to communicate all these information to the cloud. So we want to have some kind of systems through which we may send our data. So here maybe you can use MQTT, or maybe most of the cases we can use your single board computers to transfer your information through your GPRS systems. Okay. So here in this edge node, that is your 4 edge node. Here I have classified different requirements based on the situation. Say, for example, what is a microprocessor or microcontroller required? What is the memory we need? What is the flash memory we supposed to use? What is how many GPIO ports or pins we need? How we are going to connect our informations? Maybe either Wi-Fi connectivity. Why we want to have this Wi-Fi connectivity here? Because in the agricultural field, maybe you can fix this instrument in different locations, and you can get those informations through your central node. So maybe for your communication, you can use your Wi-Fi connectivity. Maybe in some cases, we may have some real-time operating system also. If you take the what are the different process, of course we are going to capture that different data, and how we are going to transfer the data without any flaw, that is data process things, that also we supposed to consider. So all these things comes under your edge node. And if you take the next node, that is nothing but your fog node, which is going to act as a mediator for your communication. So here maybe you can use single fog node or maybe multiple fog node based on the requirement. So what are the things we are going to make it with the fog node? That is your monitoring purpose. That is maybe you can have your that is algorithm through which you can get some kind of conclusion, and maybe you can give some kind of suggestion to the farmer, or maybe you can make some kind of automatic control operations. So we can include some kind of like artificial intelligence kind of systems here. So maybe you can store those data here itself, and maybe the user may be a farmer, uneducated member, or any other members. If you want to communicate your information in correct way, then we supposed to do some kind of human machine interface things. So that is one of the major process we are going to make it in the fog node. And of course the node requirements of, maybe you can use your processor, your RAM memory, or maybe your for a higher more number of data storage purpose, maybe you can use card. Or suppose you are going to connect, you are going to make it as collective information through your Wi-Fi connectivity, you can send your data. So this is your fog node operation. And if you take the third stage, that is your cloud services. So there you can monitor. That means the farmer can monitor, or the agricultural officer can monitor, or the university can monitor, or of course maybe other farmer can also monitor what is the condition happening here. So maybe we can do some kind of statistical analysis, and we can do some kind of suggestions either directly through your officer, or maybe you can adopt some algorithm, and through which we can have some kind of solutions. So that is also one of the things we supposed to consider in the cloud service. So here again the human machine interface is also required for simple communication. So here I am dividing that entire IoT, that is IoT plus agriculture. So these two things put together, we call it as IoT based smart farming. So here I am dividing that entire system into 4 different segments. One is where and all we are going to use this IoT in agricultural application, and what are the different type of devices or sensors we can use it for IoT application in agricultural application. And the third one is what all the different protocols are there are available to send your to communicate your information. And the fourth one is what all the countries they are following some specialized policies to implement this IoT. Okay. So if you take the first parameter, that is agricultural applications, again I am dividing into 3 different segments. One is precision farming, then the second one most important one is greenhouse farming, and the third one is your livestock management. So that also very important thing. Okay, if you take this precision farming, here we are going to manage different sensors, sensor parameters. We are going to take the accurate information. We are going to monitor what are the soil conditions, disease monitoring and disease control, irrigation monitoring, irrigation control. So all those things we are going to consider as a one of the primary element in precision farming. uh, Most of the cases are already exist, but one of the major thing is, say for example, if the farmer wants to make some testing for their soil, so still the farmers are hesitate to get into the laboratory for their soil testing purpose because of some constraint. So if there is any instrument or if there is any systems which can give immediate solutions or immediate result for the farmers, so that will be a very good option. Then if you take the second one, greenhouse monitoring. So of course, we are going to monitor the entire plant growth. In addition to that, we are going to take climatic conditions. And based on that, we are going to do some kind of feedback systems. That means maybe you can do water management, or you can activate some kind of elements. Soon in India, most of the vegetables are going to get cultivated through greenhouse because reason I already I have mentioned, because one is the climatic conditions. Sometimes we are getting continuous rain. Sometimes we are unable to get sunlight. Sometimes we are going to get high wind energy. Sometimes maybe because of your animals or because of birds, we are getting disturbed. That is farmer getting disturbed. So to avoid such kind of environment, even in Tamil Nadu, one of the major problem is peacock and monkey. So maybe you can because of these two major problems, the farmers are hesitate to cultivate vegetables in an open environment. So that's why better thing is the closed environment. That is nothing but the greenhouse monitoring. So that is the second one. And if you take the third one, that is livestock management. So here again, we want to do a lot of researchers. We want to do some kind of technical support to the farmers in order to support the farmers in terms of financial. Because say if you take your onion price or your tomato price, sometimes that may go up to 100 or 120 rupees. Sometimes it may go to 5 rupees or 10 rupees. So this is again because of the gap between supply and demand. Why we are getting this gap? So there is a huge communication gap between farmer and the consumer. So if there is any systematic approach, say for example based on some kind of image processing, if your system is capable of estimating how much onion is going to harvest within 2 months or within a month or within a 15 days, so based on that, what is that demand we supposed to have? So based on this calculation, maybe you can advise the farmers, yes, if you are ready to cultivate this particular crop, so definitely you will be getting good, what is that, benefit. So this is one major area, maybe we can implement our technology to support the farmers. And if you take the next element, that is different devices or the sensors, of course, the pH value and the soil sensors like your conductivity and other things. Sometimes we may use your ultraviolet sensors for measuring parameters, and maybe for animal identifications, we may go for motion detectors, and of course, moisture sensors, temperature sensors. So these are all the primary sensors. Maybe we can use it. Suppose if I want to go for secondary sensors, like if I want to measure different parameters like NPK, maybe we can use those sensors for immediate measurement. And the third one is what are the different protocols we can follow it here. So of course, this LoRaWAN is very simple one, and which is going to consume little bit amount of power, and it is going to transfer your information for a longer distance. And of course, MQTT is another one protocol. Wi-Fi we can use, Bluetooth, WiMAX, Sigfox, Zigbee, RFID. So these are all the different protocols we can use it. Based on the requirement, we can choose the corresponding protocol. And of course, the second one is IoT agricultural policy. So as far as the India is concerned, we are not having a solid solution for this particular policy, because if you take other countries like Israel and Japan, they are having an exclusive policy for integrating the technology with the agricultural sector. But in India, still we are not getting the correct policy, in the sense the government has to take some initiative to implement this IoT technology for integrating the farmers and the consumers. So that is one thing. And not only for that particular purpose, maybe for controlling purpose, we supposed to integrate this IoT with agricultural sectors. So where we are we want to have this technology, where we are going to implement this technology, or where, in which areas we may concentrate to support the farmers. Okay, so that means research challenges we are going to consider in different areas. So the very first thing, if you take, so during the cultivation process, maybe we want to have some kind of technology to monitor the cultivation. That is, during the starting stage, we supposed to monitor the different parameters, or we supposed to want to have some kind of automation systems there during the cultivation stage itself. And if you take the next one, the soil quality. So as I said earlier, the farmers, most of the times, almost 99% of the farmers hesitate to test their soils because of some kind of reasons. Maybe one of the reason may be the soil test. They are getting the result after a few days. Maybe because of the time, or because of some kind of other disturbance, they are not used to have go for this soil testing. Suppose if the system is going to give solution, that is immediate solution to the farmers on the site itself, then that will be a very good solution. Maybe because say suppose if the farmers wants to cultivate a crop in a couple of days, then before 2 days or 1 day, if the farmer is going to give uh, uh, soil to the agricultural officer or the soil testing laboratory, so maybe because of some reasons they may get that soil testing process may get delayed. But because of the climatic conditions, the farmer is supposed to cultivate the crop immediately. So that is actually a lagging parameter. So if the technology is going to support, if in terms of immediate result, so that will be a very good one. And the next one is plant growth monitoring. So how the plant pattern is looks like. So what are the nutritions we supposed to monitor? In what stage we supposed to monitor? So all those things we supposed to consider it. Maybe another thing is the what is that pattern. And the next one is nutrition management. So that is one of the major parameters we supposed to concentrate. If you take the primary nutritions like NPK, we are having some kind of testing process. That also we supposed to follow this laboratory based testing. Suppose if the IoT based system is capable of giving or measuring these three parameters in the site itself, in the spot itself, so that will be a good one. And like your secondary nutritions like copper, magnesium and all, that also very good, because most of the time the farmers uh, they are going to give this primary nutritions based on some kind of parameters. But if you take the secondary nutritions, randomly they are going to apply the secondary nutritions without doing the testing process. So we want to do some kind of testing process, or we want to take some kind of secondary nutrition information also for giving suggestion. And the fourth one is the pest control. So if you take farmers, they are spending they are giving almost 90 percentage of the chemicals towards this pest management. So that is actually a dangerous one. If we are able to detect that pest at the earliest stage, then of course maybe they can go for organic based one, or they can go for chemical based one, whatever it may be. Suppose if it is chemical based one, if you are able to identify the pest at the earliest stage, then that will be a better, because they are going to apply a small amount of chemicals to the crop. We are the consumer, we are going to consume those products. So our job is, we want to identify, we want to give some kind of earlier warning systems to the farmers, so in order to avoid uh, 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 chemical usages. And of course irrigation. So as far as India is concerned, we are having a lot of technology in the irrigation process, but still maybe we can do some kind of monitoring process, we may do some kind of integration process, so that we can do all these uh, supporting parameters in a single unit. And remote monitoring is another one. How we are going to communicate our data, that is farmer data, to others, in order to give value addition to the farmer products. Maybe you can send your data. The farmer can send the data to other farmers. Maybe based on that information, other farmers can change their pattern based on the feedback given by X farmers. Say for example, if it is two farmers, X and Y. If X farmer is following some pattern, because of that pattern, if they get failure in some situation, maybe they can give some kind of recommendation to other farmers, so that the other farmers can take the prevent action against that particular process. And the major thread is weeding process. So here also the farmer used to apply chemicals for weed control. So in later point we'll discuss all these things in detail. And of course, the weather monitoring is another one very important parameters. Yeah, marketing. So this is again yeah, one of the important parameters we supposed to consider, because as I said earlier, there is a huge gap between supply and demand in some kind of in some situation. So if the marketing procedures and other protocol exist, or if we are going to develop, then that is going to minimize the gap between the consumer and the producer. Okay. So here, most of the point we are going to use our equipments or our testing instrument or our IoT device in a remote location, rather than your like industry control. So we supposed to consider this low power parameters. That is one of the major thing. So whenever we are going to consume more power, definitely there is we supposed to take some kind of precaution for that. So of course we are storing all this energy in a battery. So we want to monitor, as well as we supposed to design our instrument such that that instrument should consume very little bit amount of power. And we are going to keep all our instrument in an open environment. So naturally we are going to have the heat, and that heat is going to affect the performance of our instrument, as well as the power consumption of our instrument. So we supposed to monitor that heat dissipation. And the another one important thing is electromagnetic induction. So because of that electromagnetic inductions, your power, there is a battery power may get wasted. So we supposed to monitor, we supposed to control that electromagnetic interference also here. And in most of the appliances, if you take household appliances, we are having energy efficient systems. Even then, if you are having energy efficient systems, if you are not monitoring those equipments properly, so definitely that is going to consume more power than the normal power. So the frequent monitoring of the equipment is very important one. And in agricultural monitoring purpose, we are not going to monitor parameters continuously. So then and then, the only 2 times or 3 times per day we are going to monitor. So if that is the case, then maybe you can move your machine under ideal stage. So whenever we want to do some kind of communication, we want to do any measurement. So during that time only we can wake up our instrument, so that we can reduce our power. So these are all the different parameters we supposed to consider while designing our IoT in for agricultural applications. Okay. So now I'm going to take different applications where we supposed to implement our technology. So very first one which I'm going to take here is your sprayer. So earlier days the farmer used to apply the nutritions or pest management through like a neem tree leaves. So through the neem tree leaves, they used to spray uh, your primary nutrition, or maybe for controlling of the pest, they had neem tree process. That is, through your neem tree leaves, uh, they deposited nutrition content, or maybe your pesticide content on the leaf of your crop. But the uniform distribution of your chemicals or your nutrition is not going to happen with that particular systems. So we supposed to have some kind of instrument which can deposit our element on the crop in a uniform manner. So because of that requirement, some scientists invented this sprayer. uh, Earlier days they used to make the seed treatment or the coating. Suppose if you are going to buy a seed from a shop, so there will be a chemical coating like your green color or pink color, like that. So that is actually a chemical coating. So in order to have uniform coating, we supposed to have the spraying process. So through this sprayer we can do that particular process. So if we take types of sprayer, normally we are having two types of sprayers are available. So one is your hand operated and another one is your fuel operated. So if you take this fuel operated, again that gets divided into two group. One is your battery operated and another one is your petrol operated power sprayer. Suppose if I'm going to use this hand operated sprayer, again the uniformity of the deposition of the chemical is not going to happen, because through our manual operation only we are going to spray, we are going to generate that pressure, and that pressure is not going to be a uniform one. Suppose if I'm going to spray the chemicals or your fertilizers through your fuel operated, so almost that will be uniform through the area, through the crop, as well as for the entire field. So here I'm going to consider one small applications, that is a self-powered power sprayer. This is simple construction of your power sprayer. Uh, uh, Here we can get the solar energy, and through your solar panel we can we can receive that solar energy, and we can directly operate your pump through this solar panel. But one of the major drawback with that system is that is going to take one drawback, that is nothing but uniformity in the spraying process. So it is better to you can keep your battery. You get that energy from sunlight, and through your solar panel you can receive it and you can store it in a battery, and you can operate your that is blower motor through your battery. So that will be a simple solutions to get the uniform deposition. So this is a simple construction of that particular solar powered sprayer. So here you will be having the nozzle. So by adjusting this nozzle, you can have the that is spraying. You can adjust the spraying area. So here I am going to demonstrate one video where we can implement our technology in this particular sprayer application.
Yeah, hi. We are from SCS Embedded. This is from Mallesh Innovations. They developed many applications, but the application is solar sprayer. It's already developed in 2013. So this is innovation project, but I'm taking the video demonstration and I'm uploading my YouTube channel. So this is Mallesh Innovations. It is a running model. So this is a solar sprayer. So it works under 20-watt solar panel, and 12 volt 9H battery is there. So it works under maximum sun availability is 10 hours. Without sun, it availability of 6 hours. So this solar panel having one fan and one light. If the solar panel will charge the battery, then we can use the night time for the fan and light for the rural purpose. So one light and one fan. So you can increase the battery. You can go for the multiple options. So this is a solar panel and the sprayer. So one DC fan is a 12 volts fan and one light. So here it's a solar panel on off button is there. So we can give the inputs to here. So fan here the on off button is there. We can on and off the button, and we can run the fan and light also. It's a solar panel. Okay. So we will see the output of this module. Just wait. Now he is wearing this solar sprayer. Yeah. So you can use many solar sprayers are available, but it's the innovative solar sprayer. So its height is very high, and it is spraying is excellent. So it's a farmer purpose. It is an innovative thought. It's Mallesh is created. It's its own idea. and it is running solar sprayer. So he's asking to video demonstration, but we are developer. We are taking this video, and so if anybody need, we are already given that number on the call. So you can call me on that number. We have a lot of solar sprayers are available. Okay. Na?
Yeah. So actually here again, the solar panel here is solid kind of things. Suppose if it is like a foldable one, we can make this entire sprayer through that foldable solar panel, so that it is not required to go for a particular angle, a particular direction. So wherever you are going, definitely you will be getting the sunlight. So sunlight may be in any directions. So, but automatically your charger gets input, so that you can use this particular application. And as I said, the weeding process. So this is one of the major important factor we supposed to consider, because this is going to consume almost 20 to 30% of the what is that money towards this weeding process. The farmers are spending almost 20 to 30% of the money for controlling this weeding process. So nowadays farmers are used to go for chemical based weeding thing. Most of you might have seen while walking to any village, throughout the entire field they used to apply the chemical. Okay, irrespective of whether the weed is present or not, simply they are going to spray this chemical. So what is going to happen if I do that? So by default it is going to reduce the quality as well as the quantity of the agricultural products. So not only that, it is going to reduce that soil fertility. So that is it is going to damage the soil. So we want to control the weed, but we want to either go for mechanical weeding process, or maybe we can go for chemical weeding process. Here we have proposed a simple that is chemical based weeding process, which is going to apply the chemical only for the targeted area, not for throughout the field. So that is our aim. So whenever you are going to use this herbicide or weedicide, whatever it may be, so it is going to consume. That is, that particular weedicide also going to affect your plant also, but that is indirectly is going to generate health problems. In some cases, it is going to create like a cancer kind of things. So finally, it is going to affect the soil. So we want to have some kind of mechanisms, or we want to have some kind of technology, so that we can avoid such kind of process. So here we have developed that is innovative automated electromechanical weeder. So that is going to spray the chemical, but not throughout the field, only to the targeted area. So by default, we are going to avoid the soil contamination. So how we are going to obtain this? So through some kind of morphological property only it is possible to obtain. So we followed that one. So that's why we proposed a simple precision based autonomous vision systems for weeding purpose. So once if you are going to use this precision spraying, then automatically it is going to reduce the herbicide usage, and it is going to protect the environment from the chemical. So what are the problems we are having with the conventional spraying? As I said, the farmers are depositing the chemicals throughout the area. Okay, it is not only the targeted area, all the areas they are going to apply. So we want to develop a simple system so that it is going to do this process only for the targeted area. So we have proposed a simple model by using a single board computer, that is Raspberry Pi. So this is the entire block diagram of the developed systems. Actually, we have developed this instrument for row-based crops like turmeric and banana, sugarcane. So wherever we are having the row-based crop, we can use this particular robot for this chemical, the weed control purpose. So the methodology here is through your camera, we are going to take that image. and that image we are send it to your single board computer, that is nothing but your Raspberry Pi. And in that Raspberry Pi, we can use your OpenCV or any other tool to do your image processing algorithm. And after completion of that image processing algorithm, you can send your essential component to the other controller, which is going to control the spraying nozzle. So here, actually, this single board computer is going to take some time to do the image processing. So that's why we have implemented this controlling part through other microcontroller. So we are sending the data through your serial communication, and this microcontroller is going to receive the data, and that is going to activate the corresponding valve, solenoid valve, and based on your input data. And of course, if I want to use solar energy for powering purpose, sorry, maybe we can use solar module to charge it. So what are the different stages we supposed to follow for this particular precision spraying? So here I have taken 3 steps. The very first one is we want to capture the image from the field, and whenever I'm going to take an image from a field, it is going to be like your background. You may have your soil. Then in addition to that, we are going to have the plant. So here plant is nothing but that includes your crop, and that is your crop and the weed. Okay. So we want to segregate the plant and the background. So that means your weed and crop is one category, and the background, that is nothing but your soil, is another category. So through your excess green and excess red, it is possible to segregate it. So by using this formula, excess green and excess red, it is possible to segregate your background and the plant. Okay, now I am having the plant. That plant has 2 parameters. One is your crop and another one is weed. So we want to segregate our crop and the weed. So that is the another stage we supposed to follow. So if you take crop like your turmeric, banana, or your what is that sugarcane, the leaf area will be more. Okay, so through area based classification, it is possible to segregate your crop and weed, so that you can identify which one is weed, which one is crop. So after identification of this, okay, now I know weed is there. So now in an image, I classified weed and crop. So now I have taken only the weed alone. Okay, now the weed may get spreaded in different areas. That means you may have some 2 to 3 leaves. So we want to find out where exactly it is located. So we want to go for the region-based drops in order to find out the centroid of that particular weed. So after finding of that particular centroid, then we supposed to take X and Y position of that particular weed. So once if you are obtaining that X and Y position, okay, you can send that information to your controller, so that the controller is going to activate the corresponding nozzle. So here the image size which we have taken here is 640 cross 480 pixel. Okay. So now I want to do all this process as an autonomous process, not a manual process. We want to make it as autonomous. So for row-based crops, we are going to have furrows and ridges. So based on number of furrows and ridges, we want to make an algorithm so that your robot is going to travel in a correct direction and in correct manner. So here we have developed an algorithm to track your furrows and ridges. So this is your simple pictorial representation of how the robot gets moved. Maybe in your video it is very simple to understand. So this is actually a developed model. So it consists of, this is your water tank, that is nothing but your pesticide control element, or maybe your nutrition control things, you can keep it here. And you may have like your camera. This is a solenoid valve to activate nozzles. We have taken only 4 nozzles because 1 to 1.5 feet maybe the area where you can travel. That is, the robot can travel. So this 4 nozzle is enough to cover that particular area. And we have 4 different wheels. 4 wheels are independent wheels because we want to make different actions while traveling. So through your pump, we are getting the pressure. So through that pressure, we are spraying the chemicals. Okay. So the processor we have taken here is a Raspberry Pi. And in order to identify the ridges and furrows, we have used ultrasonic sensor. In addition to that ultrasonic sensor, we have used accelerometer to identify the position of your robot, because this is not going to be a robot which can travel in a what is it, smooth surface. So we supposed to operate this particular robot in a rough surface, that to soil and different conditions. So we want to know, we want to adjust the position of robot based on parameters. So that's why we have included that accelerometer. So let us see the video demonstration of that particular developed model. So initially we have developed that model and we tested in a laboratory. So in 3 sites, we kept ultrasonic sensors to detect that furrows and ridges. So in order to make automatic travel path. So after that, we tested without any crop and other elements. Just we made a artificial furrows and ridges. So actually, we have used only the proportional controller. Suppose if there is any integration of your PID controlling process, then the turning process may be a smooth one. So before start of this process, we supposed to give how many ridges and furrows are there in that particular thing. Then automatically it is going to do that navigation process. But the condition here is in both the sites, we want to have equal number of ridges and furrows. So once it gets completed the given task, then it will come out of that particular area. Okay, this is actually without any disturbance. That is, maybe if you take the soil conditions, sometimes we may get dry, sometimes we may get wet. So running that robot in a dry condition is very simple, but running that robot in a wet condition is a tedious process. So that also we tested with some changes in the soil. And finally, before getting to the actual process, we have tested without any load, how it is going to move. So if you see here, this is actually a simple setups we have made. So this is without consideration of your situations, that is whether the weed is present or not. So normally the farmers used to apply the chemicals throughout this particular area. So here, the this particular robot is going to detect the weed, and it is going to spray the chemicals only on that particular selected area, not in all the areas. So actually, we faced a lot of problems while moving wheel under different environment conditions because of like small stones and other disturbance. So that's why we made it as a chain based one. So finally, we have developed this under this chain based control. So one of the drawback with this particular system is it is going to take some time to recognize. Okay, even in the video itself, we could able to identify how much time it is going to take to identify the weed. So if there is any algorithms or any kind of processor which can do the image processing tool very faster rate, so that will be very good one for faster completion of the task. Yeah. So the next one which we have developed was chlorophyll meter. So I think everybody knows about this chlorophyll. So for better growth and for better quantity as well as quality requirement, we supposed to monitor this chlorophyll also. So that is actually a for photosynthesis process. This chlorophyll content plays a major role. So it is going to help the plant to get energy from the sunlight. So this chlorophyll directly linked with the nitrogen content available in that particular crop. So based on the nitrogen content available in the soil, the crop is going to get that nitrogen content. Okay, so suppose we say if your system is capable of identifying the present chlorophyll content, and if you are able to give the suggestion to the farmers, yes, you want to apply this much amount of nitrogen content so that you can get the good chlorophyll content. So that will be a very good one. So here, this particular instrument is going to support, or it is going to give the estimation of the chlorophyll content present in that particular crop. So this is a simple absorption rate of your leaf. Okay, this is applicable for most of the crop. Okay, so here we are having two chlorophyll, that is chlorophyll A and chlorophyll B, and it is going to, so this spike is nothing but how much amount of energy is going to absorb, percentage of energy absorption. So in this particular range, that is from 450 to 470 nanometer, so it is going to, that is your crop is going to absorb more amount of energy. And if you take in this side, so here, for example, 650 to 690. almost 670 or 680, you're again this chlorophyll is going to consume, it is going to absorb a lot more energy from the sunlight. So this is one of the key factors we supposed to consider to design or to estimate your chlorophyll content. So before get into the actual developed model, we supposed to know what it is, what all the different technologies are there, how the farmers are using this chlorophyll measurement. So as I said earlier, it consists of two chlorophyll, chlorophyll A and chlorophyll B. So it is going to absorb, this chlorophyll is going to absorb more energy, that is there is a wavelength, that is violet to blue and orange to red light. So this is the range your chlorophyll A is going to absorb more energy. And if you take chlorophyll B, so this is going to again absorb the energy, but this is under green light. But if you take this chlorophyll and A and B, this chlorophyll A contributes more than chlorophyll B during the photosynthesis process. So that's why we have concentrated only for chlorophyll A, not chlorophyll B. Okay. So these are all the different technologies are there for measuring the chlorophyll content. So in earlier days, the farmer used to measure this chlorophyll content by seeing the leaf color itself. Okay. So if it is in yellowish color, it means that the nitrogen content is low. If it is dark green, then the nitrogen content is more. So it is not required to apply the nitrogen content. But that is actually one of the rough estimation. And if you take the actual original as chlorophyll measurement as your leaf extraction method, that is, we supposed to pluck the leaf from the crop and we supposed to give it to the testing laboratory through your chemical process. They are going to give the test result, and based on that we can identify what is the chlorophyll content. Okay, so here the drawback is it is going to take some time, and we supposed to hand over this particular sample leaf to the testing laboratory. That may take some times. Okay, so that is a major drawback, but the accuracy if you take, that is good. And the next simplest method is chlorophyll chart, that is leaf color chart method. So this is actually applicable only for paddy field, but for this is not applicable for other crop. So by comparing the colors with the that is available in your chart with that of your plant, you can estimate how much chlorophyll is present. So based on that, you can suggest the amount of nitrogen content we supposed to apply. So that is again another one rough estimation method. And this is again based on the color. Maybe we can adopt our technology like image processing tool to identify the color of the leaf, and based on that you can give your solutions. But the drawback with that one is we want to go for like image processing systems that may take larger processing time, and the cost also huge. Maybe if it is MATLAB based, then of course we supposed to go for like a laptop based one. So one of the simplest method is this that is wavelength measurement. Okay, so by measuring the absorption rate of your crop leaf, it is possible to identify what is the chlorophyll content present in it. So this is a simple pictorial representation of the chlorophyll meter. So here we are having two major elements. One is a transmitter and another one is a receiver. So as I said earlier, red color, blue color is there. So this is the wavelength at which your crop is going to take more energy from the sunlight. Okay, now I am artificially generating that wavelength, and I am going to test how much energy it is going to take. Okay, so here just by using your red color LED and blue color LED, you can pause your light, and through your receiver, optical receiver, you can able to receive your data. And what is the need for this IR sensor? So the major reason for this IR sensor is actually this instrument we have developed for multiple crop, not only for single crop. This is applicable for multiple crop. So if you take turmeric leaf, the leaf thickness is different. If I take a banana leaf, the leaf thickness is different. So based on the leaf thickness, we want to estimate the chlorophyll content. So the leaf thickness is one of the parameter which is going to affect that reception rate. So we want to consider that also. And after receiving all these informations, that is through your optical receiver, we supposed to do the amplification, and maybe you can give it to your controller to do the estimation process. So here maybe you can take multiple reading in different stages. it is not required to pluck your leaf from the crop. Just you can insert your leaf between the transmitter and the receiver. Thereby, you can maybe it is going to take 2 to 3 seconds to do the process. Then you can take your readings. So one of the major problem with the other system is we are going to take only one time. But here there is an option called average. So you can take multiple readings, and in order to reduce the error while taking reading, one of the simplest method is taking the average. So you can do that process. So after taking all this information, if I want to send that information to the IoT, yes, you can communicate that information to through your Raspberry Pi or any kind of instrument. So suppose if I want to make it as like a self-generated power, so of course the usual procedures, we supposed to put your solar panel through your buck boost converter. You can get that energy and you can store it in your battery. Okay. Suppose if I want to have on-spot result, here LCD display is there, so you can get that result here itself. So we have designed this instrument for measuring chlorophyll content of 3 different crop, that is sugarcane, turmeric, and banana. Maybe we can extend this particular process for other crop also. So this is the principle behind this chlorophyll measurement. So actually, one instrument is there. That is a SPAD instrument is there to measure your chlorophyll content. So that is actually one company who manufactured this chlorophyll meter. So that's why they named SPED. And of course, they have given the reading in terms of SPAD also. So in order to compare our instrument, that is developed instrument, with that of the standard instrument, we want to have the conversion method. So that's why we have made this formula to convert your chlorophyll content index into SPAD index. Okay, so this is a simple method to translate to that. So in order to find out the CCI, this percentage of transconductance at 950 nanometer with that of 650 nanometer. Similarly, we want to make it for this 425 nanometer. So the next one is turmeric finger growth characteristics monitoring. So turmeric is one of the major crop that is cultivated in India, and in every home we are having this turmeric powder as an ingredient for any kitchen related purpose. So here the thing is finger growth monitoring. Why? What is the need for this finger growth monitoring? Actually, if you take other crops other than this finger, maybe you take banana, or even you take your sugarcane, you can able to visualize the result by seeing that crop itself. But if you take turmeric, so it is not possible to visualize that growth of that particular crop, because we are having the finger under the soil. So we want to have some kind of mechanisms to monitor this finger growth. So that's why we have proposed a simple method to monitor that. So we have used 3 different sensors: flex sensor, temperature sensor, pH sensor to take the measurement. Okay, now come to this particular thing. So here, if you take the first figure, so this is a high yield turmeric finger. Okay, so if you take the second one, this is actually a finger. There is no finger growth at all, because so during 4th month to 6th month, or between 4th and 6th month of the turmeric cultivation, so one of the major disease of gets affected is rhizome rot disease. So it is required to monitor the turmeric growth. If that rhizome rot disease gets affected in a particular crop, so immediately that is getting spreaded throughout the field. That is a major problem. So automatically the farmers are going to lose their yield. So that is one thing. Then another thing is, it is okay, if there is any rhizome rot disease, that gets reflected on the leaf, but it is going to take at least 30 to 45 days to get reflection on their leaf. So between 30 to 45 days, so all this rhizome rot disease gets spreaded over the field. So it is required to monitor the rhizome, that is your rhizome rot disease. In addition to that, it is possible to monitor the turmeric finger growth. So during the 6th month, we are going to get that rhizome rot disease. So once if you are having that rhizome rot disease, there will not be any growth in your mother feed. This is actually unpredictable because after 30 to 45 days only it is possible to get that particular disease on the crop. That is a major problem with this particular thing. So we have introduced a simple mechanism so that it is possible to identify the rhizome rot disease at the earliest stage itself. So here, in addition to that, we have included this pH and soil sensor that is not directly related to this rhizome rot disease. Here our main concentration is rhizome rot disease. Okay, now this is a simple block diagram representation of that particular developed model. So in randomly we have fixed this particular instrument, and we have collected all these readings, and based on the readings obtained from that node, it is possible to identify whether that particular crop gets a required amount of growth or not. So we will be having this the signal conditioning unit for different sensors, and through just microcontrollers we can capture all these informations, and we can monitor those informations in that particular spot itself, or it is not required to monitor in that particular spot itself. Maybe you can fix this instrument randomly in different locations, and through your Zigbee or any kind of wireless technology, you can transfer those information to the center node, and the center node can send those information to the cloud. Okay, so this is a simple setup. So you can transfer your data, collect the information from different node, you can send it to your cloud. Yeah. So this is how we have made that flux sensor setup. Okay. So flux sensor is a simple flexible sensor. So based on the bend angle, we are going to get the change in resistance. So during the plantation of mother feed, we are going to fix this flux sensor in all the sides except the top, in all the sides, left side, right side, back side, front side, bottom. So during the plantation, you are not going to have this finger growth. So you'll be having only the mother feed. So after 3 or 4 months, you are going to have the growth in your finger. So every day we are going to monitor the flux sensors reading. And if the rhizome rot disease gets affected, immediately you are not going to get any changes in the finger. So thereby you can identify that rhizome rot disease immediately, so that the farmers can take the necessary action at the time itself. Okay, the next one is monitoring this particular what is that irrigation process. So there are different technologies are there to control or to monitor the irrigation systems. So here, one of the simplest system is you can get that what is that electronic valve. You can put different sensors in different field, and based on the data, you can activate your valve. Okay, that is well established systems we have so far. But one of the drawback with that particular existing system is, so maybe if it is distributed land, for example, 1 hectare or 2 hectare land, we supposed to use 10 to 15 gate walls to control the irrigation process. So it is a cost consuming one, because we want to lay pipeline in different locations, and we want to make it as common. We want to keep all these gate valves in a common place, and you can control your gate valve through your solenoid valve. So that is going to consume lot of money. The other technique is you can distribute your gate valve in different location, but you want to lay a wire from your EB room to the gate valve to control your gate valve. So that is actually not permittable, and that is actually a dangerous one. So we want to have some kind of mechanism so that individually we can control it, and we can save our cost. Okay, so that's why we have proposed a simple mechanism here to control this irrigation process. Okay, so this is your say for example, you consider different gate valves are there. So in each and every gate valve, I'm going to put a small turbine, that is hydro turbine. So whenever you want to activate, you want to irrigate that particular field, you are going to activate, you are going to pass the water into this particular pipeline, and thereby you are going to get the rotation on your hydro turbine. So through that hydro turbine, you can charge your battery. Okay, that is one method. Sometimes maybe you can use your solar energy, and you can store that energy into your battery. You can, that is another one method to get energy. But the advantage with this particular system is it is actually a distributed system. Like that, you can have n number of gate valves. That is actually a distributed one. So we are going to operate our gate valve in that particular distributed system itself, and there is no need to make a line from your EB line to your what is that control location. So through your battery, you can control your systems. So we have proposed a simple mechanism. This is actually a simple demonstration model where you could find three different turbines. So this is actually for manual control purpose. We have made this control. So whenever if I want to make a irrigation in this particular field, I'm going to open this gate valve. So whenever I'm going to open this gate valve, so definitely there will be a water flow. So through that water flow, I'm going to get this rotation in my turbine. So I'm going to charge my battery from this turbine. This is one input. And in addition to this, we can charge this battery through your solar energy also. Yeah, come back to this system. So if you take this electronic gate valve, that is going to take more cost. That is actually around 6 to 7,000 rupees we want to spend for controlling a single gate valve. Here, if you take the manual gate valve, this is actually a manual gate valve. This cost around 300 to 350 rupees. And if I want to control this gate valve, yeah, we want to use some kind of some electromechanical system. This is actually a used wiper motor, which can have high torque to control this particular pipeline. So this is actually a second-hand motor. This cost around 500 to 600 rupees. So this is within 1,000 rupees. It is possible to make this gate valve control applications. So through your battery, you can control this wiper motor, so that you can control your irrigation systems. So like that, you can have n number of modules, n number of turbine. That is actually a distributed one. Okay. So this is another one area where we supposed to consider. That is pest control is the major area. So almost 35% of the what is that cultivated seeds gets wasted because of different situations. Okay, because of your birds, because of your what is that flower growing process, because of your seeding, because of fruit harvesting, because of leaves. So there are different things are there. And another important thing is insects. So we want to have some kind of mechanisms to control that insects. uh, uh, if your system is capable of giving solution without chemical, that is actually a good one. So here, this is a simple mechanism. Let us see that video. Then I'll explain what is the process behind this. So this is actually an animal repellent. Okay, so here say it consists of, yeah. So it consists of your PAS sensor, which is going to detect presence of movable objects. Say for example, animals or birds like that. So you'll be having this ultrasonic generator. So it is possible to adjust that density of ultrasonic waves by adjusting knobs based on the requirement. And during daytime, okay, maybe you can control your animals maybe through in persons or maybe through this particular ultrasonic. But during the night time, some animals may not get disturbance because of this ultrasonic signal. So we are having this LED flashlight. So once if the animal is present, so automatically it is going to detect through your AR sensor, and this LED is going to give flashing. So once if you are having a flashing, then automatically your animal gets repelled from your field. That is the aim of this particular instrument. Yeah. So the next one is a drone. So one of the very famous drone was MG1. Okay, that is actually a very powerful, which can capable of having a high payload. That is up to 10 kg. It is possible to handle it. So for spraying, we can use our manual sprayer, or maybe we can go for your fuel-based sprayer. But this drone-based fertilizer management or pest management is one of the advanced technology where we can get faster operation and automatic operation. That is one of the major things. So whenever we are going to use this drone-based systems, it is going to save almost 40 to 60 times. That is, it is faster than 40 to 60 times faster than manual spraying operation. That is one. And it is possible to adjust your nozzle based on your what is that requirement. Say for example, in a particular area you are having high disease, in a particular area you are not having disease at all. So why you want to spray your chemical on the non-disease area? Just you want to spray only the particular area. So if we want to take some kind of intelligent systems, so that that intelligent system is going to make decision, and it is going to spray your chemical only on the particular required place itself. Okay.
我是一名植保无人机飞手，从事植保作业已经有半年时间。我的每天的主要工作是给南瓜和玉米打药。以前我就很关注植保无人机，但是学习飞行和操控很困难，需要很小心的去飞行。在试用了 MGES 以后，我发现这是一台很智能的植保无人机，它让作业变得更简单。每次作业前拿着遥控器绕着农田走一圈，就能直接规划好航线。下次作业时。
So this is actually a GPS-based mapping systems. So once if you are having once the spraying process gets completed, then automatically you can get that information through your IoT.
一名植保无人机飞手，从事植保作业已经有半年时间。我的每天的主要工作是给南瓜和玉米打药。以前我就很关注植保无人机，但是学习飞行和操控很困难，需要很小心的去飞行。在试用了 MGES 以后，我发现这是一台很智能的植保无人机，它让作业变得更简单。每次作业前拿着遥控器绕着农田走一圈，就能直接规划好航线。下次作业时直接调用数据就可以了。设置好喷洒参数和作业模式，上传到植保无人机以后，就能开始自动作业。操作简单，而且效率很高。我们一天能完成400-500亩的作业。
有的田块不平整，手动调整高度很难，经常会喷洒不均匀。MGES 配备了3台雷达，飞的时候可以自动定高，完全不用担心掉高影响喷洒质量。最终的喷洒效果是最重要的。MGES 配备了双水泵，可以分别控制前后2对喷头，比 MG 的喷洒精度更高。喷洒速度和飞行速度是联动的， 飞行速度不稳定的时候，也能做到均匀的喷洒，不会烧苗，也不会漏喷。对于植保队来说，飞机一定要便于维护和修理。MGS 进行了结构的优化，很多部件都可以拆分，需要修理的话很便捷，成本也低了不少。
现在有了无人机打药，给我们农民节省了很多时间和精力。以前像我们这块地，一个工人一天才打4亩。
So this is actually a manual spraying.
2分钟就可以搞定，无人机打药，喷洒均匀，效果很好。玉米叶子的背面、茎部都可以喷到。以后有紧急的病虫灾害，就不再担心没有工人给我们喷药了。
1年以来，我们的植保队由3个人增长到30多个人。现在我们多架无人机在附近的村镇同时作业。NGES 配备的大疆农业管理平台提供了整套的管理方案，打开平台就能实时查看每台飞机的状态和作业进度，可以直接统计工作量进行结算，还能把已经规划的任务指派给飞手，节约了很多测绘的时间。有这个平台以后，我们的工作更有条理，更方便，效率提高了很多。大疆无人机植保解决方案给我很大的信心。今年我要扩张无人机植保业务，为更多的农户服务。
Yes. So next thing is solar-based water pump control systems. So that is another one area where we supposed to concentrate. So nowadays the government is encouraging the farmers to adopt solar-based irrigation systems. But the problem with that particular system is, say during the night time, it is very difficult to operate your motor. That is one thing. And another thing is, based on your battery operated systems, it is possible to do that. But if you take that maintenance cost, then that is actually a huge one. So we want to do some kind of energy efficient systems so that you can operate your systems during the early morning, or up to for example up to 6 o'clock if it is possible to operate your instrument. So that is well and good, but that is actually a direct conversion. So from the solar panel, we are going to operate our instrument. There is no battery backup. So we supposed to have some kind of optimized algorithms or optimized conversion procedure, so that your system is capable of giving the good result. So that will be a very good one. So if you take your solar based your motor irrigation systems, so one of the problem is conversion from DC to AC. So while converting from DC to AC, we are wasting a lot of power. So through some kind of MOSFET and some kind of conversion algorithms, we are translating. Okay, so let us see one simple examples where we can incorporate energy, that is IoT technology, as well as some optimized technology to translate the sunlight energy into direct AC signals. So from the sunlight, we are going to receive that solar energy, and through solar panel, we are converting that into DC. And of course, we are having only the induction motor. So for operating your induction motor, we supposed to have AC supply. So that too, 3-phase AC supplies we want to have. So the major research record here is the inverter. So we want to have some new innovative technology which can convert your DC from solar panel to directly AC. That is one of the important factor we supposed to consider it. So this is one video where you could find the application of your IoT and your algorithm for improvement. So that is actually a variable frequency drive. చూడు ఒకసారి దీని నుంచి గాలి వస్తుందా లేదా. So this is actually a fixed angle solar panel. So if any system is there that is going to track your sunlight, and that tracking is going to give more energy than this instrument, so that will be a very good one. So most of the cases we are going to get pulsated AC from variable frequency drive, but there are some kind of algorithms are there to convert your pulsated DC, that is your DC or AC, into your pure sinusoidal signal. Then that is going to give more energy, that is efficient one. So here it is possible to control this solar panel from a remote location through your IoT. It is possible to monitor your energy level, what is the energy consumed, how much energy it generates in that particular day. After 6 months, or say for example 1 year, so your solar panel gets a lot of dust. So if your system is capable of detecting that particular dust that is deposited on the solar panel, and if your system is going to communicate that information to the user, then the user can take the immediate action, or maybe automatic system we can make through, so that you can control your what is that management of your dust through your automatic system. That is also one of the parameters we supposed to consider. Okay, now another one area where we supposed to concentrate is, that is your fruits. So if you see here, I have projected two different type of fruits. One is your banana with yellowish color, that is uniform yellowish color, and another one is again the banana, but the uniformity of the yellow is not there. Somewhere you are going to get green color, somewhere you are going to get dot colors. So here, if you take the first figure, not only banana, even if you take your what is that mango, mangoes are gets ripened through different kind of chemical process as well as the natural process. But here our ultimate aim is to detect whether that particular fruit gets ripened through natural or artificial. So we want to develop some kind of mechanisms to detect this particular process. You know, in most of the cases, that is, we are getting fruits from the artificial ripening process alone. Say, for example, there are two kind of process normally they are following. One is ethylene liquid and another one is carbide stone. So nowadays the shopkeepers are not using this carbonate stone for ripening, but ethylene is the general one. Everywhere they are following this ethylene. Say if I'm spraying that ethylene liquid, after 4 hours you can get yellowish color in your on your fruit. Most of you might have experienced this particular thing. Say the fruit may looks like yellow, but if you are going to touch that particular fruit, you may find hard, because that particular fruit gets ripened through your artificial process. That is actually the natural phenomena here is, if any crop is going to turn into yellow, it is ready to eat. That is the communication given by any fruit. But if anything is made through artificial, so then it is going to looks like yellowish color. But if you are going to if you are trying to eat that particular fruit, it looks like very hard. So that is the major problem. So we have proposed a simple mechanisms through that we can identify whether that fruit gets ripened artificially or naturally. So actually our aim is through your mobile phone, you want to make this decision. That is, you want to make a that is you want to take a image of that particular fruit, and you want to send it to your cloud, and you can make some that is, you can have some kind of algorithm in the cloud, and that cloud is going to give some kind of decision to the user. Yes, that particular fruit gets ripened artificially or naturally. That is actually our aim. So through histogram, we have tested for banana fruit. So, but again, this is actually through your MATLAB. But we are looking for a simple technique only by using your mobile phone. We want to get that result. That is our ultimate aim. So this is still under progress. Yeah. So as I said in the third slide, the greenhouse monitoring is one of the very emerging area, because soon we are going to get all our what is it, vegetables from the greenhouse. So the greenhouse monitoring is very important. So here we are going to consider two things. One is inside parameter and another one is outside parameter. So if you take the inside parameters, the carbon dioxide, relative humidity, solar radiation, vapor pressure, temperature, all these parameters we supposed to monitor. So similarly, we want to monitor different parameters like what is the rain, humidity level, what is the wind, speed, direction. Like that, we want to monitor the different parameters. So here, one company, they have developed this greenhouse monitoring and controlling of the greenhouse from a remote location. So actually, before get into the actual developed model, they have demonstrated or they have tested through SolidWorks. This is actually a prototype model. So based on the sunlight, if I want to close the, if I want to reduce the sunlight radiation, then maybe you can move the curtain. This is actually a multi-purpose unit. If I want to make a dryer, you can make it as a dryer also. So main thing is we want to control the temperature. Either we want to increase the temperature or we want to reduce the temperature. So there are two systems are there. One is heater and another one is cooling element. So it is possible to interconnect your instrument with computer, so that may be a very good interfacing mechanism. They have used two mode of operation, manual mode and automatic mode. So in manual mode, you can have simulated result on the screen, as well as you can have the control in the field itself. This is actually a direct GUI tool to control your different parameters. So in automatic mode, there are two things. One is simulation mode and another one is your actual automatic mode. In the simulation mode, if I set some different parameters, then it is going to give simulation, how it is going to look like, how it is going to behave. So once if you are satisfied, then you can go for the implementation mode. That is your automatic mode. Yes, that's all I have. Any clarifications?
Dear participants, this is the time for question and answer session. If you have any doubt, kindly post it in the chat box or else raise your hand. We will unmute you. You can directly discuss with our resource person.
So here I have just projected the different areas where we want to concentrate, where we want to have a lot of research.
Dear participants, if you have any doubt, you can ask. So there one more question from participant side, sir.
Yes, sir.
If
Sandeep, I
working
think.
with
Yeah.
any ready data set available in India,
Actually, we want to make a data set, sir. That is the problem here. That's why I have chosen only a selected field, not a different field. So I have a data set for turmeric leaf alone.
uh, thank you, sir. Actually, already one person asked a question, sir.
Okay, sir.
During that banana rifle checking,
Uh, could you please tell me that question, sir?
yes, sir. It's possible to change the direction automatically of the solar panel based on the sunlight position.
Yeah, that is possible, but that is actually because of some power consumption or constraint, they have not made it practically. But if we are capable of giving efficient system, so that you are going to consume a very little amount of power to track your solar, then that is a very good one.
Yes, sir. Then there is one question
If
about
we
that.
make
It's a wheat control system. If
yes.
we make our own data set, means then there is any issues of data set validation.
Sir, actually, we are looking for solving some kind of problems to the farmers. So if your system is giving the solution to the farmers, and that is actually a proof of concept you are having. What is a validation you want to have? Maybe for your conference paper, or maybe for your what is that journal papers, you want to have some kind of data set, that to medical applications. But if you take the agricultural applications, the proof is enough, sir. You want to have strong proof or evidence for your work. That is enough.
Thank you, sir.
Thank you, sir.
No. So let me conclude the session, sir.
Yes, sir.
Yes, sir. We will conclude the session, sir.
Okay, sir. Okay.
People will forget what you said. People will forget what you did, but people will never forget how you made them feel. I hope that Dr. S. Maheswaran made you feel about the importance of IoT in precision farming. Associate Professor, Department of ECE, Kungu Engineering College, Erode, for providing the wonderful practical session on the topic of research challenges and application of IoT in precision farming. On behalf of management and the Department of ECE, we once again thank you so much, sir.
Thank you, sir. Thank you to all the participants for their patient listening. Thank you, sir.
Thank you, sir. Dear participants, the day 4 session to attendance and the feedback link is posted in chat box. Kindly fill it soon. It will be open up to 30 minutes only. Dear professors, the day 4 session to attendance and the feedback link is posted in chat box. The link is available in chat box. Kindly fill it soon.